Hi. So today we'll discuss about steric inhibition of resonance. So this is also known as SIR effect. Now, what is this steric effect? Steric means simply bulkiness. Okay? Or you can say large in size. Okay? So when any group is large in size, then it causes steric effect or space factor. Inhibition means it becomes a problem, it creates a issue. Okay, so it is an obstacle. So steric inhibition of resonance. Now for resonance, very important factor is coplanarity, right? The atom having lone pair or negative charge or electron density should be in a coplanarity with the ring or with the system. Only then resonance is possible. Now when due to some reasons, due to this bulkiness of some group, if this coplanarity is disturbed, then resonance do not take place. And because of that, lots of factors changes like acidity, basicity, okay, so lots of bond length, all these factors changes. So I'll try to provide you some examples so that you get a clear idea. Suppose in this first example, here it is iodine, NO2, NO2, NO2. Okay. Now, this is also NO2, this is also NO2, this is also NO2. So, this might look symmetrical, isn't it? Now, experimentally, it was found that there are two different types of CN bond length. So, these two bond lengths are same, but this bond length is different. And it is experimentally found that the bond length A is greater than B. Now, what could be the reason? Okay, so we have to look into the molecules. So, what could be the reason? Now, here see. This NO2 group is like this, and here also. Now we all know iodine is already bulk in size, it is large in size, right? Now it is large in size, this NO2 group is like this, is very large in size, it is spread out over a very very long distance, isn't it? So there is this steric factor comes into play, right? Now there is another nitro group. Now because there is now these two NO2 groups are creating a problem due to their size. What happens, this iodine, in case of these things, this iodine and everything, what happens actually, these two NO2 groups, now this lone pair, this electron density is no more in resonance with this ring. Okay, actually there should be this resonance, this 3 NO2 groups should be in resonance with this ring, but here this resonance do not take place, and here also the resonance do not take place because their coplanarity is now disturbed. Okay, they go out of plane, so that they are no more in a plane with this benzene ring, so that there can't be any resonance. But here you see there is this 2 hydrogen only, so they are very small in size, they are not creating any problem for this NO2, right? So since they are not this, for this NO2, these 2 hydrogens are not creating any problem, here resonance is possible. Here resonance is possible like this. NO2 group has minus M effect. Okay, so here it's possible. So what is the structure? The structure look like this: positive, double bond, O minus, isn't it? So now this CN is now having more double bond character. but they are not having double bond character, they are only having single bond character. That's why we all know the single bond is in greater in bond length. That's why A is greater than B. So I hope you understood the concept here. Now in the next problem, we all know Friedel-Crafts alkylation. Now here, those who don't know, I'll try to make a separate video later. So this is tart butyl group, this is tart butyl benzene. Okay, now if I want to if I want to put this alkyl group here, okay, now this is tart butyl group, this is activating group, so the group will enter either ortho position or para position. Okay, now if you use anhydrous AlCl3 and this CH3Cl, what actually happens, I'm writing this group like this. Actually, this is found around like 99%. There are no ortho substituted ortho alkyl tart butyl benzene. Why? Because this is already very bulky. So CH3Cl can't enter here. Okay, because this is already in bulky. This is already bulk in size. But here there is no such issue. That's why we get majorly this para product. Now let's move to the another example. There are many examples, but in this video I'll try to show like 2-3 examples. Now the next example, here 2-methyl group is present, NMe2, and here 2-nitro group. Okay, here also 2-nitro. Okay, now what happens, this is large in size, this is also large in size, again steric inhibition, right? Because of this the coplanarity is now no more there for the resonance, so this bond rotates to decrease this steric inhibition. Okay, now this bond is no more in the same plane with this benzene ring. This bond just rotated, so that now the steric factor is less. So this lone pair is now no more in conjugation with this ring, no resonance. No resonance here is happening. Now what will happen? Since no resonance happening, the lone pair is now available here, isn't it? So there the lone pair is available. Now suppose if there was no steric hindrance, suppose the group was like that. Suppose it was like that. NMe2, it is having lone pair like this. Now what will happen? This NO2 group has minus same effect, so it will withdraw electron towards itself, isn't it? Because now it's small hydrogen, no steric inhibition. This lone pair is in planar with this benzene ring and also this NO2 group. Now since this is in resonance, this lone pair becomes unavailable, so it is less basic. But here there is no resonance, so that's the reason it becomes more basic. Okay, now last example. Suppose there is NH2, okay, not NMe2, NH2, and here NO2 group. Very interesting example. NO2 group, here also NO2. Now see, their hydrogen bonding, 2 hydrogen bonding is there. Now because of this hydrogen bonding, there was supposed to be steric inhibition effect. Steric effect should play here. But since there are 2 hydrogen bonds, now this has to be in plane no matter what, because this 2 hydrogen bond restricts this NH2 group, so that now the NH2 group, this bond has to be in plane. This bond can't rotate. Okay, So since now these all are in same plane, so resonance happens. This NO2 group is having minus I effect. So since resonance happens, this lone pair becomes less available, so it becomes less basic. So these are some examples. This kind of questions come in your exam. So I'll try to provide many more examples in the second video. So if you like it, please like, share and subscribe. Please support me so that I get the I actually get motivated to give you more and more videos. Okay, thank you. Bye bye, take care.